All right, so this is note card 64. And the title is Angles of Elevation and Depression. Angles of elevation and depression. So the angle formed by a horizontal line formed by a horizontal line. And don't forget, horizontal looks like this, like the horizon. So in our picture, we're going to have a horizontal line. That's important for this. Okay, so the angle formed by a horizontal line and the line of sight up to an object is called the angle of elevation. The angle formed by a horizontal line and the line of sight up to an object is called the angle of elevation. So what we're defining here is angle of elevation. That's the new vocabulary. So you should underline that because it's towards the end of the sentence. And then how this works is, if there's a person, so I apologize in advance for my pictures. They're not super good. I'm not an artist, that's for sure. But there's a person here, and let's say there's a plane up in the air. And normally, hey, don't laugh at me. I told you ahead of time not to laugh. Okay, so there's the person, there's the plane. So normally a person is looking straight this way, horizontally. So it's very important to have a horizontal line in your picture. So here's the horizontal line. And then, but to look up at the plane, the person has to be looking upwards. So the line of sight is going from the person's eyes to the plane. Okay, so there's a horizontal line, and then there's a sight line. The line of sight is where you're looking, and the horizontal line is the flat line. And the angle formed by that horizontal line and the line of sight, that's this angle here, that's called the angle of elevation. And it's elevation because you're looking upwards. Okay, then the other term for today, the angle formed by a horizontal line and the line of sight down to an object the angle formed by a horizontal line and the line of sight down to an object is called the angle of depression. So underline that because that's the vocabulary that we're defining here, angle of depression. Okay, so maybe in this picture there's a person standing on top of a cliff. And again, horizontal lines are key. In this definition, there's a horizontal line. In this definition, there's a horizontal line. So that's the main thing that people mess up about these. They forget that there has to be a horizontal line in the picture. So make sure you have your horizontal line, which looks like this. Actually, that's going up a little bit, so let me make it totally flat. And then maybe there's a boat down here. Again, my pictures are terrible. Sailboat down there. So what's going on is the person is looking down. So the sight line is there. So here's the line of sight. Here's the horizontal line. And the angle between those, that's called the angle of depression, because it's going down. So you usually look straight out, but if you're looking up, then that angle is an angle of elevation, or if you're looking down, then that angle is an angle of depression. All right, that's it for the note card. So the paper is called Angle of Elevation and Depression. Title is Angle of Elevation and Depression of the paper. And we're going to start with number 3. You don't need to write this problem down. So Joe and Sally are visiting Kings Island. Sally is at the front gate, and she's looking at Joe, who is on the observation deck of the Eiffel Tower. The way the Eiffel Tower is, you can go to the very top, or there's a level up just a little bit. That's called the observation deck. So Joe isn't at the top, he's at the observation deck. And the angle of elevation for Sally is 35 degrees. And the question is, how far is from the Eiffel Tower is Sally? Okay, so the first thing you have to do with these word problems is you have to draw a picture that goes with it. So here is Sally at the front gate. Doing some curly hair so you know it's Sally. I know my pictures are terrible, I'm sorry. And then the Eiffel Tower is over here somewhere. So here's the tower. Here's the very top of the tower. But Joe is not all the way at the top. He's on the observation deck. So here's Joe. So Sally at the front gate on the ground. Joe up in the air a little bit because he's on the observation deck of the tower. Right, so Sally's at the front gate, and she's looking at Joe, who is on the observation deck. So her sight line, her eyes are looking in this direction. So that's called the line of sight. Okay, then it's talking about the angle of elevation. So when you have an angle of elevation or an angle of depression, what kind of a line do you need in the picture? Yeah, Alex? A horizontal line. I can't emphasize that enough. Horizontal lines are going to be in the picture. This is the thing that people mess up. All right, so here is the horizontal line. And then it says the angle of elevation for Sally is 35. So that's between the horizontal line and the sight line. So there's where the 35 degrees goes. And then there's some more information that I haven't written down yet. It says the observation deck is 275 feet above the ground. So the question's asking how far from the Eiffel Tower Sally is. So here's Sally, here's the Eiffel Tower. So that distance is what the question's asking for. How far is she from the Eiffel Tower? So I'll put an X there, because that's what we're looking for. The question didn't tell us, that's what the question is asking, how far she is from the Eiffel Tower. But we do know that the observation deck is 275 feet from the ground. So here's Joe on the observation deck, and then the ground is down here. So this is 275 feet. Okay, then what kind of an angle is this? A 90-degree angle, right? Because this is a horizontal line, and then the Eiffel Tower is going straight up and down. So that's a 90-degree angle. And that's a big deal, because when we have a triangle that has a 90-degree angle, then there's a lot of stuff we know about 90-degree triangles. There are 4 formulas we have now that work with right triangles. Pythagorean theorem, which we've had for a long time, that works with right triangles. And then sine, cosine, and tangent work with right triangles. So on this one, we have the angle, so we're going to use either sine or cosine or tangent. So the 275, is that hypotenuse, or opposite, or adjacent? Yeah, Maddie? It's opposite from 35. See how the 275 is across from the 35? So that means it's opposite. All right, how about the x? Is that hypotenuse or adjacent? Yeah, Emma? It's adjacent, good. It can't be hypotenuse because the 90's here, so hypotenuse is here. So that's why this is the adjacent. All right, so they gave us the opposite, that's 275, and they're asking us to find the adjacent. So we have to then look up which trig function is opposite and adjacent. Yes, sir. Sorry.
Cosine?
Actually, no. Opposite and adjacent is in cosine, but it's not opposite and adjacent. It's cosine.
Oh, so you're saying opposite is the numerator than adjacent is?
That's the way it goes for one of them, yes. Which one? That's okay. Yeah, Kieran?
Tangent.
It's tangent that's opposite and adjacent. Cosine is adjacent and hypotenuse.
Yeah.
Good. All right, so we're going to use tangent on this one because they gave us the opposite and we're going for the adjacent. And tangent is opposite on top and adjacent on the bottom. So it's 275 over x. And then what goes here after tangent? The 35 degrees. Whenever you write sine or cosine or tangent, you put an angle after that. So tan 35 is a fraction, and the fraction that it equals is 275 over x. Everybody okay with the setup? Then you look up tangent 35. Either look it up on the trig table or use your calculator. Comes out to 0.7002. And then as a fraction, that's 7,002 over 10,000. And we know that that fraction is equal to our fraction, 275 over x. This is the tangent fraction that the calculator knows or the table knows. And this is the tangent fraction that we got off of our triangle. And we know that those fractions have to be equal. And then you just do cross products. You take 275 times 10,000 and divide by 7,002. Anybody got that number for me? Yes, ma'am. All right, 392.7. Yeah, we had to round. Actually, when we wrote this down, we were rounding already. So yeah, definitely. That's why I put the squiggly equals there, so we would know that we don't have the exact right answer, we're rounding. So that means that the front gate, where Sally is 392 feet from the bottom of the Eiffel Tower. All right. Next one I'd look to look at is number 10. So number 10 says square root of 32. And the directions say simplify the square root. So what do you have to do when you simplify a square root? Yeah, it's been a while. That's why I'm throwing this kind of a problem in. Yeah. You break it up into two things multiplied that equal 32. Good. All right, so what are two numbers that multiply to be 32? Yeah.
4 and 8.
4 and 8 is an option. Good. Other options for 32? 16 and 2. Good. Both of these are fine. This one is quicker because 16 is bigger than 4. So then the square root of 2 is a nasty number. So we're not going to figure that out. We're just going to recopy it. But the square root of 16 is 4. So it's okay to go to and figure out that part of it. So square root of 16 equals 4. We wrote that down. Square root of 2, don't want to figure that out. So I'm just leaving it. And then the final answer is 4 times the square root of 2. So if you typed 4 times square root of 2 into your calculator, you'd get a nasty decimal. If you typed square root 32 in your calculator, you get the same nasty decimal. This is equal to that. Yeah?
Wouldn't next year be wrong if I did like 2 square root of 8?
It wouldn't be wrong, but it wouldn't be 100% right, because you can break this down further. And then eventually you get to that answer. But it's a lot quicker if you can go this route. And you would get most of the points if you wrote that down, because you have the idea, but you would just get a little bit off because you didn't go as far as you could. All right, and then last one I'm going to look at with you is 12A. So there's a triangle on 12. Looks like this. It's a right triangle, which is good because we know a lot about right triangles. Pythagorean theorem and sine, cosine, or tangent. But this one says specifically to not use sine, cosine, or tangent. And we're trying to find the missing sides. So how do you find missing sides if you're not allowed to use sine, cosine, or tangent? Yeah. Okay, so this is a special triangle that it's not only a right triangle, but it's a 45, 45, 90. The reason we know these are 45 is because they're equal. So they both have to be 45 if they're going to go with the 90. And there's a formula that just works on 45, 45, 90 triangles. And that is the hypotenuse equals the leg multiplied by the square root of 2. So this formula is fair game only on the 45, 45, 90 triangle. And that's why we don't have to use sine, cosine, or tangent. So the 4 that they gave us, is that the leg or is that the hypotenuse? It's the hypotenuse. So it goes for h in the formula. So I've just plugged in 4 for the hypotenuse, because on this particular triangle they told me the hypotenuse is 4. Now I'm trying to figure out x, but it's multiplied by the square root of 2. So to get rid of that, I divide by the square root of 2. So that crosses that out. And that tells us that the missing side that we don't have is 4 divided by the square root of 2. So this is the correct answer, but there's something that we don't like about this. What don't we like?
The denominator.
Yeah, you're not supposed to have a square root in the denominator. So we're supposed to go one more step and do what's called rationalizing the denominator, which means we're going to get rid of the square root. We've got 4 divided by root 2, and we're going to multiply it by root 2 over root 2. It's okay to multiply by this because it equals 1, so we're not changing the value. So we're going to multiply across the top, and also multiply across the bottom. The square root of 2 times the square root of 2 is the square root of 4, but then the square root of 4 comes out to 2. So the process we're doing right now is called rationalizing the denominator. And then you can even go one more step. The 4 divided by the 2 is 2. So now we've got 2 times the square root of 2. So that means on this triangle, this missing side is 2 times the square root of 2. What's this missing side? Same thing, because on a 45, 45, 90, it's an isosceles triangle. So these two sides are equal to each other.